Hello, Internet. Today we are going to attempt to write a Terraform provider for Lambda Labs. This is very useful if you want to, provision resources and you don't want to do it manually, like here clicking buttons on the dashboard like a fucking ape. So in order to mitigate that, we are going to attempt and write a Go module that is going to integrate with Terraform, and we will use that maybe to provision an instance. This will be probably the first part of a series of I don't know how long, and hopefully we'll make it work. And if not, then well, too bad. I'm sorry. I can't be perfect. And this is actually going to be a little bit hard because, first of all, Terraform kind of sucks. And provisioning instances is actually quite difficult because, well, Lambda Labs doesn't have a lot of availability, but we will do our best and we'll try to do something. So without further ado, by the way, the process we're going to try to mimic is basically following the REST API. If we'll go over what's going on here. As you can see, we are listing the available instance types, we are listing the file systems, listing the SSH keys, and we are we are refreshing whatever the available instances are. And if we click them, we can actually like select the zone, select the file system, or provision a new one if we'd like to. And then we can provision the instance. Let's just pretend we're going to do something here. So that's going to be temp delete me later, and we can create the file system. This is basically now a post request that actually provisioned the system. We are selecting the SSH key, and then we launch. I will not launch the instance right now because that would cost us money and I do not have use for that instance right now, but this is basically the what we're aiming to what we're aiming for. So now let's actually go hop over to my GitHub where I have cloned the template of HashiCorp's scaffolding for creating a new Terraform provider. We are on the main branch and there's nothing here. There's just the scaffolding. If you look at the log, basically we've got the initial commit, which was auto-generated by GitHub. And we can now go build, probably. Let's read the docs. Implement a provider using with the Terraform plugin framework. Hi, so from the editing room here. Apparently I have wasted about 10 minutes about like cloning the incorrect template and stuff. So I just followed the tutorial instead of like cloning the template from GitHub. So I'm going to just cut like, I don't know, like 5 or 10, 8 minutes from like the video and hopefully things will make sense. Enjoy. Bye. Awesome. So we have renamed our Go module. Go mod tidy. That will probably do not a lot, but oh, I see. Now it downloads everything. Sure. And we can now do this thing. And that's why it didn't work before that, because when we scaffolded the module, we haven't renamed it. So yeah, that wouldn't have worked. Anyway, it now says we can remove that and paste this and only change that to Lambda Labs. Awesome. Yeah, okay, this seems to be a little bit happier. Let's move on. Okay, Docker Compose. I'm not sure why, but I'm going to basically trust them because we probably would like that. Create the Docker Compose. What is this? Conf JSON. Interesting. I didn't know we can Docker Compose with JSON files, but this is nice. Not a Go file, just a file. Conf JSON. Moving on. Docker Compose YAML, sure. Docker Compose YAML. Interesting. I don't think we'll need that in the end, but sure, we'll figure it out in a minute. Yeah. So let's go to internalprovider.go. Internalprovider.go. I'm zooming out a little bit because I want to actually be able to see what I'm doing. So I hope you will excuse me. Ensure scaffolding provider satisfies various provider interfaces. Type scaffolding provider model struct. Okay, not interesting. Schema, metadata, configure, resources, data sources. New returns this. Okay, cool. So this is just a very rough scaffold of code. We might want to actually, okay, let's actually run these side by side, and hopefully this will be useful enough. Okay, open the provider and replace the existing code with the following. Replace, interesting. How different is it from us? Let's paste that in for a minute. That wasn't copied at all. Where's the copy button? There is it. There it is. Okay, so let's actually look at the diffs. So instead of importing whatever that was with framework types, we are copying other things. Okay. The new method is now above and not below everything. It was here somewhere, if I recall correctly. So we have now replaced the content to be like a little bit more the thing that we're aiming for. Okay, so we have pasted this content in and implement the provider server. The Terraform providers are server processes that Terraform interacts with to handle each data source. And the resource operation, such as creating a resource on a remote system. Later in these tutorials, you will connect those Terraforms to a locally running HashiCups API. Okay, that's that's why it's like the HashiCups provider. Basically, it's going to provision apparently cups or something. Sure. Start the provider server process by implementing the main function in the code execution starting point for Go programming languages. A long-running server will listen to Terraform requests. Framework provider servers also support optional functionalities such as enabling support for debugging tools. You will not implement this functionality in these tutorials. Open the main.go file and replace the content with the following. So let's replace it, apparently. Replace. I'm quite surprised. Let's replace that. And let's actually look at the content here. So not a lot has changed. Or has it? I see some imports that are missing, so we can actually try to just okay, let's undo this because apparently this looks already quite good. HashiCups, Lambda Labs. And let's actually only replace the main function because, well, it's only the main function that they're trying to change. And it looks the same apart from like this address. This is not a typical Terraform registry provider address, such as registry.terraform.hashicups. This specific provider address is used in these tutorials in conjunction with a specific Terraform CLI configuration for manual development testing of this provider. Okay. Cool. We might want to change that to Lambda Labs. We'll see. Okay. I think we're good. Yeah, we should have only we only needed to actually replace the main function, nothing else. Verify the initial provider. So go run mod main go. Go run main go. It says this is the binary plugin. Yeah, okay. So exit status 1. Prepare Terraform for local provider install. So Terraform init. Terraform allows you to use local provider builds by setting a dev overrides block in a configuration file called Terraform RC. So first, find the go bin path where go installs your binaries. Go env go bin. Sure. Apparently. So let's set this file. Sure. Then Terraform RC. And we've got our path. We need to paste it right here. So let's just paste that. And we can now write for all other providers, install them directly from their origin provider registries as normal. If you omit this, Terraform will only use the dev overrides. And so no other providers will be available. Okay, so that's very good to know. Sure, let's moving on. So we just wrote our Terraform RC file, and back to the guide with everything by our side. Now that we're mostly reading, let's actually replace the spaces of these. And if we'll go back to coding, then I'll replace the windows again. Okay, so we can now go install this. So let's go install. And we can make examples. So let's do that. And in our example, we can make this thing. So let's make the thing. Let's switcheroo again between our things. Let's browse to our examples. Provider install verification, and we can make this with how do they call that? Maintf. Yeah. That's the quote unquote entry point, but Terraform doesn't really have an entry point. Okay, and this is now going to be Lambda Labs, Lambda, and provider Lambda Labs, and data coffees. This is interesting. I'm not sure this is actually going to work now. Yeah, the provider does not support that yet. You will implement the data source in a future tutorial. Awesome. Okay, so we can now run Terraform plan on this, maybe. Let's see we are within the install. Yeah, Terraform plan. And it says that we need to run Terraform init, which is completely reasonable. And it says HashiCorp.com, given provider resource Lambda Labs, does not offer a Terraform provider registry. Interesting. Provider registry HashiCups does not have package available on your current platform, Darwin AMD64. Wait, why are we seeing HashiCups at all? I thought first of all, it should be this one. But let's actually look for HashiCups. Yeah, so that should be Lambda Labs. And still, let's try Terraform init, and this is still going to be like quite sad. And it says, warning, provider development override are in effect. Lambda Labs and go bin. Skip Terraform init when provider development overrides. It is not necessary and may error unexpectedly. Okay, so Terraform plan. And it says invalid data source. Okay, very good. I think this is where we wanted to end up. Okay, navigate to, well, to the root of our directory, nothing fancy. Next steps. Congratulations, you started the development of your own custom Terraform provider. Later tutorials will show you how to implement the data source and resource functionality. If you're stuck during this tutorial, check out the provider branch. Okay, cool. So let's continue on with actually implementing the thing, the data source, and then we'll try to implement, I don't know, the next stuff. So Where's the next step? Check out the provider branch to learn more about the plugin framework, full capability comparison, blah, 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 blah. Next, configure client. Is that the thing? Okay, that's the custom provider. Configure a shared client requiring authentication with provider configuration. Implement data source. Do we need this one before this one? This is probably stored in the right direction. So yeah, let's continue. Navigate to your HashiCups, blah, 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 blah. Implement provider schema. Okay, so I think we can continue. Schema defines the provider level schema for configuration data. So it's going to be host, username, password. Implement provider data model. PFSDK. Okay. Seems like we're just going to copy that and not think about it so much. So let's just do that. Provider go. And within our provider, we look up for the schema. And we replace the schema with this thing. And it says could be Lambda Labs Provider. Yeah, sure. And any more HashiCups? No more HashiCups. Okay. Implement provider data model. So this is going to be still within the thing. Add your data model definition to the thing. Okay, so where does it need to sit? I don't know. And the fact that we don't see this one is actually going to probably be annoying at some point. Error. I'm unsure why this is not working, but we will probably do that in a minute. So we've done that. But we do have still some compilation errors. Have I missed anything? Probably not. Okay, let's just move on. Replace the import block with this. Okay, so that is going to be this thing. And this one says HashiCorp demo app HashiCups client go. Kind of sad. Well, I really wanted to use like the HashiCups. Okay, so this is working, but I really don't like the fact that we're actually calling that HashiCups client now. But sure, let's just move on and we'll be fine, I hope. Okay, we replaced our imports. We can now go get this thing. So let's just go. Let's fetch that quickly. Already fetched. And go mod tidy, go install. Go mod tidy, go install. Git go install dot. And let's currently spin up our Docker. So yeah, cd docker compose up. Do we need to detach? No. So let's spin it up and let's actually do that in another tab. So docker compose up. Okay, so we've got ourselves our database and a lot of insert 0 1s or something. I don't know. Let's not worry about like what's actually running in this Docker at the moment. And let's continue on. We can curl readies. I like the ready with the Z. So okay, that's nice. Export HashiCorp HashiCups token. So let's do that. And we can now export that as a token. Not all of the JOT, only the base64 sign token. Anyhow, let's move on. The terminal containing HashiCups logs will record the sign-up operation. And we can see that quite certainly here. Let's see, and it says duplicate key because, well, I've signed up twice, but it should somewhere say handle user, sign up, tracing middleware, complete, received. Yeah, okay, sure. Anyway, seems to be working. Beginning for sign up, handle sign up complete. Yeah, so all of that happened, basically. Implement temporary data source. So let's create coffee's data source. I think this is like a really nice tutorial in the sense that what we're going to do is basically, once we finish that tutorial, we're going to basically just string replace whatever like HashiCorps with Lambda Labs, and instead of whatever like coffee data source, it's going to be our machines or file systems, basically. So that's going to be HashiCorps. So add the temporary data source by creating a file with the following. I'm not sure why they call that HashiCorps here and internal provider coffee cups here, but sure. Okay, we now pasted everything in. We don't need to really see what's going on here. I think it's going to be quite a trivial thing. Let's see what does it say. It says new coffee data source. It returns a data source, type, struct, metadata, schema, read. Yeah, so nothing actually happening here. Open the providers go thing. So yeah, let's just, and we can now add this to our data source. So resources, data source, paste. And that's going to be our Lambda Labs provider because we have we've done some find and replace stuff. And back to our thing. Let's just go install again. And we can now see into the examples, I would guess, and into the verify installation and Terraform plan. And it will now say missing HashiCorps, blah, 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 blah. And we can export that. And it says use HashiCorps password or username or host or something. And within our thing, it says, well, a lot of stuff. So run Terraform with the following environment variables. So no changes. Awesome. Your infrastructure matches the configuration. By the way, I really like the fact that this tutorial is actually also like including the errors in between. This is like super positive. Okay. Where have we got to? We can now make the coffees. So, okay. Let's go and make some coffees. I'm guessing there's a lot of like suspiciously similar coffees examples on GitHub for unfinished tutorials. Where are we? Required providers, HashiCorps. That's going to be Lambda Labs. In our case, so Lambda Labs, and again Lambda Labs, HashiCorps going to be replaced by that, and HashiCorps coffees as Lambda Labs coffees, and we can now Terraform plan that, and it will say probably nothing because, well, that's the whole point. So see, we are in coffees, and it says no changes. Amazing. So in our actual provider, we will need to provide, well, the host is going to be by default just Lambda Labs' API. It's going to be like usually not overridable. And the only thing we'll need to provide is an API token, not a username and password. So that's going to be a little bit different from this provider, but this is the point here is that we will now be able to actually figure this thing out. Anyhow, remove the temporary data source. So sure. Yeah, we need to probably see the out of whatever that thing is. So yeah, okay. Now we have removed that. And we can patch things up again in the providers. Yeah, everything. So far, things completely make sense, which is nice. And just need to back this into Lambda provider. And we can now go install things again. Okay. And next steps. We are now prepared to communicate. So yeah, okay. Moving on to the next thing, which is a data source, an actual one. So you will implement a data source to read the list of coffees from HashiCups' API and save it in Terraform's state. To do this, you will define the initial data source, add the data source to provider, implement HashiCups' client in the data source, define the data source schema, define the data source data model, define data source read logic, and verify data source behavior. This ensures the expected data source behavior. Prerequisites, everything that we've done so far. Continuing from this tutorial's new setup. Okay, so we are in the continue from previous tutorial. That's very good. Okay, so apparently we could have left this and just replaced the content. I don't know why they told us to RM this file. Anyhow, so we've got again coffee data source go, yeah, and within that, copy the contents, copy the actual contents. Yeah, we paste that in. Add data source to provider again. So this is our data source once again. Implement functionality in the client. Okay, so this is actually going to do some stuff. So within our clients, we've got our coffee struct data source. Coffee data source, where are you? Yeah, and we've got the HashiCups client. Yeah, this is going to be replaced by the actual HTTP client of Lambda Labs once we've got that. I think I will attempt to generate the Lambda Labs client from the Open API spec. That way, we'll only need to like auto-generate the Go code and then just patch it up to Terraform state. Hopefully. But who knows if that is going to be actually useful. Replace the import statement with that. So I think we are already good. I don't know. Ensure your data source implements data source with configure. We now need to probably do something about that. So coffee data source, so data source with configure. So we need to func coffee data source configure. It receives a context, a request, and a response. And if the provider data is nil, we return. Otherwise, we create a new client. Provider data, we pass the client in. If that's not okay, unexpected data source configuration type, expected HashiCups client got T. Please report this issue to the provider developer. Okay. So let's just copy that in and let's put that right here at the bottom and implement the data source schema. So let's actually look at the data source. This is going to be, oh, this is a terrible way to define structs. Sure, let's just get on with it. So we've got map of coffees. Okay, wait. Response schema. The schema has attributes which are a map between string to something, and the something is schema attribute. And then we point where coffee is pointing to list nested attribute, and then it says computed true nested objects ID, name, user description, price, image, ingredients, blah 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 blah. Okay, so a lot of boilerplate. Yeah, I'm guessing writing code like this Go code is basically going to make Copilot super happy, but not me super happy. And we need to probably override the schema here. So we already had an empty schema. Now we're going to override that with this huge verbose schema. Terribly terrible. I would like to define those in like Pydantic or TypeScript, basically. Sure. And we also need to replace the type coffee data source model. So where's our model? We don't have a model yet. Okay, so this one is new. So let's define it somewhere around here. And these as well. So these types are, yeah, from this area. This is like Terraform types, not usual types, I guess. Yeah, this is important. So we will have probably like more debug information. It's not like primitive structs. It actually has more data and functions attached to it. Anyhow, currently we need to replace this import thing again. Probably nothing interesting. Implement the read functionality. Where's the read? Yeah, this read function is still empty. How does it look? We define a state. Within that state, which Go is always angry about us that we don't use the state. So coffee is error. D is our data source. Our data source. Okay, so get coffees. So get coffees is actually coming from the actual client. So not very useful. This is going to, like, I don't know, issue an HTTP request, I would guess. Yeah, do a request. And once we fetch that, we map the response body to model. So yeah, this is the crap that basically this is like we basically need to like patch auto-generated code with like the real world. So let's just read that quickly. What we've got is we are iterating over all the coffees that came back from the client. This is just an array, and for each of the elements, we are going to map between whatever it is. We're going to just like build up the structs and then append them into our state. Yeah, okay. Very, very procedural, very like C-like, I would assume. I mean, no, not even C-like. Like actually initializing structs in C. Yeah, it looks like that, sort of. Anyhow, and then we are setting the state with diagnostics. Okay, doing like a bit of like error handling and diagnostics is quite nice. Yeah, okay, let's go install that, and we can probably, verify that. So let's go to our coffees and Terraform plan. It says no changes. Okay, so we probably want to, yeah, okay. So let's actually update that. Where's our coffees? Coffees main. We've got our thingy, and we want provider Lambda Labs. Within that, we want to say coffees. So a provider. Who? Resource. Output, sorry. Output. Lambda Labs coffees and value data Lambda Labs EDU. Yeah, seems good. And let's plan. Okay, so this is our output apparently, which has coffees. HCP AeroPress, Packer. Okay, awesome. I like the fact that they're Terraspresso. Yeah, they basically. I like the Easter eggs here. Perk up and watch out for your access management boundary red eye waypoint. Okay, nice. I really appreciate the Easter eggs. I guess there are probably more Easter eggs than I can think about, even like within this. Anyhow, so far I'm very happy with this tutorial. Next steps. So, do we want to like apply that? Probably not. Or I mean, this is probably not even ready to be applied. You have implemented the data source in the provider that uses the configured API to save Terraform state. Okay, so the plus sign means that basically our rights here, if we look back to this thing, the fact that we can say here, so this is our actual state. Basically, this update here, like this is our actual like Terraform state. And we are, when we are appending stuff here, we are actually doing the thing. So that's quite useful. Okay, so sure, I think we can move on. Next, logging. I think we're gonna do like one more section of this guide, and then I'm gonna call it quits for today, and I will see you. And after that, I will see you in the next part. So stay tuned, because I think we're like making a really nice headway, and hopefully we will figure this out. Okay, so internal provider go in configure. We can paste that in, and what will we get in return? We will get like a log line when we're configuring this stuff. So where is our configure map function? So configure. Yeah. So if log the thing. Okay, awesome. Already updated because Golang is nice, and we can also set these. Where's that? Has errors. Has errors. If response diagnostic has errors, and here we've got context. Yeah, so right about this area. Or you know what? Actually, after we do all of this crap. So you've got the create a new HashiCorp thing. Yeah, okay, that's the point. That's the spot. And we can also, at the end of everything here, we've got client, we can log the thing. Okay, and implement log filtering. And, ooh, that's nice. So here we can say mask field values with field keys. Yeah, seems good. Seems like the right way to go. So we are going to like log that, but we're not going to like we're going to mask the secret value, which is nice. And we can now go install and run that again, and we will see a little bit more nice stuff. So cd back into this area and go install. And cd back into coffees and Terraform plan. And let's look at the logs, apparently, because probably this will now say some things. So it says read complete after thingy thing, nothing fancy. If log trace. Interesting. So Oh, a lot of tracing. So let's actually look up for coffee because apparently we've got a lot of stuff to. Terraform is chatty. Oh shit. Um, starting visit, pending dynamic subgraph, blah blah blah. Oh my god, so much stuff. Where's the client? Oh, this is super chatty. So it says using. What if we say only like info, or is it like the debug info? What verbosity level have we chosen here? It says set field context debug. Okay, so first of all, let's actually select debug and not trace because I think that's the thing we aim for. We don't need the trace thing. So okay, this is a little bit quieter, and now we can actually see the creating HashiCorp's client probably in the logs. So creating HashiCorp's client. Yeah, okay, very good. So we now know how to dump some crap into our logs. Very useful. Okay, so that's logging. Save Terraform into trace. No, I don't need to do that. Yeah, basically, yeah, we've done that by looking in the terminal. We don't need to save that into a trace. Anyhow, view specific Terraform log outputs. So we can, yeah, set the log level. That's, I mean, that's not interesting in the terms. Okay. Okay, cool. So we now have added some logging. We've added our Terraform provider. We can now read the state from this HashiCorp's provider. And in the next steps, we will, I don't know, create and read. Awesome. So I think we're not going to do that today. I think this is very nice for, I don't know, about an hour and a half of like reading through the docs and like doing stuff. And yeah, I'll see you in the next video. I think hopefully in the next video we will actually attempt to provision something real and or at least read something some real state and not like use HashiCorps, but who knows? I'm making no promises and you should join me and have fun with me as I do that. See you in the next video. Bye bye.